नमस्कार दोस्तों, मैं आपका बहुत बहुत स्वागत करता हूँ यूट्यूब चैनल पर जिसका नाम है दयाल साइंस क्लासेस। और लेके आया हूँ आज आप सबके बीच CSN की सीरीज फिजिकल केमिस्ट्री से पार्टिकल इन अ बॉक्स की सीरीज स्टार्ट कर रहे हैं आज की इस वीडियो के साथ। इस वीडियो को शुरू करने से पहले हम लोग क्वांटम केमिस्ट्री में पार्टिकल इन वन बॉक्स and videos related operators we have already discussed about them. So now we are going to discuss about previous year problems based on particle in a box problem that has been asked in previous years. Today we are going to discuss two problems from June 2012 and one problem from June 2013, which is directly related to particle in a box problems. So let's begin. The first question is from June 2012. First question says find out the probability of finding a particle in a 1D box of length L in the region between L by 4 and 3L by 4. And the options given to us were A 1 by 2, B 1 by 2 plus 1 by 5, C 1 by 2 minus 1.5, and D is equal to 2 by 3. Now let us see. Now in order to solve this, we first know, let us first check what is the wave function for what is the wave function psi? What is the wave function psi for particle in a 1D box? For psi for 1D box is given as under root 2 by L sine n by x upon L. In this question we were also given that n is equal to 1. We have to take quantum n is equal to 1. The principal quantum number will be 1. So basically you can write this for psi n, for psi 1. It is for n equal to 1, psi will be equal to for 1D box, general psi value function will be equal to under root 2 by L into sine of n by x upon L. Now here in this question we are given that we have to find the probability of 1D box for principal quantum number n equal to 1 and in the region L by 4 to 3L by 4. So we will replace this n by 1 and what we will get? This implies psi will become root 2 by L into sine of pi x upon L. Right? This will become this. This relation will become this one, will get reduced to this form expression. Now let us see what will the probability. I will denote probability by capital P x. Probability, since we are talking in 1D box, that's why I am using Px. Px will be equal to the probability of finding particle in 1D box is given by integral of sine square dx, and since we are required to find the probability region is L by 4 to 3L by 4, so our lower priority will be L by 4 and higher priority will be 3L by 4. That is, within this region, integral of psi square dx within the limits of L by 4 to 3L by 4 will give me the probability of the particle present in this region, in the region L by 4 and 3L by 4 for 1D box. Now I will put the value of psi from here. What I will get? I will get integral 3L by 4 into 2 by L sine square pi x upon L dx. So what I will get this expression. Now 2 by L is a constant term that I can take outside the integral sign. What I will be left with 2 by L integral of 3L by 4 into L by 4 sine square pi x upon L dx. Right? I hope this much is clear. Now the integral of this sine square pi x upon L is equal to इसका integral. Now, so till now what we have got is that the Px is 2 integral 3 by 4, 3L by 4 sine square pi exponent dx is the probability. Now what we need to do is we need to integrate this. Now integration of sine square pi xl, I just tell you one relation you need to remember in order to find this. You just have to remember that integration sign. If you are a mathematical student, then you can easily solve it, but if you are not from the mathematical background, then you might have a bit problem in solving this integration. So what I'll do, I will give you the direct expression, what will be the integration of this function. You can directly apply this in the problems, whichever comes in front of you. Now integral of, if we have integration sine square and theta. If we have sine square, integration sine square and theta, with respect to the theta, the integration will be equal to theta by 2 minus theta by 2 minus, it is theta by 2, remember that, this theta by 2 minus 1 upon n cos 2 theta. One upon 2n cos 2n theta. The integral of sine square n theta d theta is equal to theta by 2 minus 1 by 2n cos 2n theta. I hope you get this. The integration of sine square n theta d theta will be equal to theta by 2 minus 1 by 2n cos 2n theta. Sorry, not cos, sine 2n theta. Sine 2n theta. I hope this is clear. I hope it is visible to you that what we have written here is the integration of sine square theta d theta, which is equal to theta by 2 minus 1 by 2n into sine of 2n theta. Now to solve this, now here if we compare this integration, what do we see, what do we find, that this n here, which is written as n theta here, n is, here theta will be x and n is pi by l. So what I will get here, if I integrate this, I will get 2 by l x by 2 limits l by 4 to 3l by 4 minus 1 upon L upon 2 pi sine 2 pi x limits 3L by 4 to L by 4 is the limit. Now when we solve this limit, what I will get is equal to now 2 by n. Now in integration, when limit is applied, it is applied as first we put the value of x as upper limit minus the lower limit, upper limit minus the lower limit. Now let's put 3L by 4 in place of x. If we put 3L by x by 2, we put x is equal to 3L by 4 in x by 2, what will we get? Let's say x by 2 is equal to 3L by 4 you will get 3L by 8. 3L upon 8 minus. Now when we put this L by 4 in x by 2, what will get? L by 8 minus L by 2x, sorry, 2 by. Now, first we will put x equal to 3L by 4, what will get? L and L get cancelled. 2 will cancel this L, we will get sine 3 pi by 2 minus sine of pi by 2. Now when we put L by 4, we will get sine pi by 2. This is 1 and sine 3 pi by 2 is minus 1. So what we will get? 2 upon L into here. If we subtract, we will get 2L upon 8 minus here what we will get? L upon 2 pi into minus 1 minus 1. Minus 1 minus 1 gives minus 2 and minus 2 into minus 1 will give me plus 2. What I will get? 2 upon L into now here 2 will cancel it as 4. We will get L by 4 minus L upon 2 pi plus into 2 gets cancelled. Now we multiply 2L by 2 by L inside, what will get? 1 by 2 plus something. I will get it as it's 4 pi minus 4 pi 4. Alright, so what I will get is as 1 upon now if I multiply this 2 by L inside, what I will get is 1 by 2, LL get cancelled in both the cases, and 2 when divided by 4 will give me 2, I get 1 by 2. Now here 2 into 2 4 and divided by 4 we get 1. So what we get? 1 upon 5. So the correct option was option number B, 1 by 2 plus 1 by pi. The probability of finding the electron in 1D box in the region L by 4 to 3L by 4 is 1 by 2 plus 1 upon pi. I hope it helps. I just repeat once again what we have done is, first we have written the wave function for particle in 1D box of length capital L is under root 2 by L sine n pi x upon L. But in the question we are given that we need to find the probability of finding 1D box for quantum number and quantum number was given as n, value of n was given as 1. So the psi for the problem will be psi is equal to under root 2 by L into sine pi x upon L. Then what will it? We find out the probability. What is the probability? Will be equal to the integration of psi square dx in the limit L by 4 to 3L by 4. The limit L by 4 to 3L by 4 shows that we are finding out the limit in this particular area, in this particular region. Now, when we put psi square from this value, when we put the psi square in the probability, what do we get? We get 2 by L sine square pi x upon L dx. So now 2 upon L was a constant. We took it outside the integration sign. What are we left with? The integration of sine square pi x upon L. And integration of sine square and theta, we know that integration of sine square and theta d theta is given as theta by 2 minus 1 by 4 and sine 2 and theta. So what do we get is, so the integration of this becomes, so the integration of this becomes 2 by L into x by 2 limit L by 4 to 3L by 4 minus L by 4 pi into sine 2 pi Lx into and the limit will be L by 4 to again 3 by L by 4. Now substituting the limits, we'll get 3L by 8 minus L by 8. When we substitute the limits in x by 2, we'll get 3L by 8 minus L by 8. Now when we substitute these limits in this expression, what we get? Sine 3 pi by 2 minus sine pi by 2. Sine 3 pi by 2 is minus 1. Sine pi by 2 is plus 1. So minus 1 will be minus 2. Minus 2 give me minus 2. Now what we did, and what do we get? When we subtract this, we get L by 4. Here we'll get 2L by 4 pi. When we multiply 2 by L inside both this term, what will be? The LL get cancelled, and we will get 1 by 2 for this. L by 2 by L multiplied by L by 4 give me 1 by 2, and 2 by L multiplied by L by 2 pi will give me 1 by pi. Therefore, the probability is 1 upon 2 plus 1 upon pi. Now let us check out the second question. What does the second question say? In the second question is again from June 2012. Now we come to the second problem. In the second problem it says there is a particle in a 3D cubic box of length L and it has an energy of 14 h square upon 8 ml square. We need to find out the degeneracies of energy state. Now let us first see what is the general expression for the energy for a particle in a 3D cubic box. For a particle in a 3D cubic box, energy is given by n square h square upon nx square plus ny square plus nz square into h square upon 8 ml square. This is the general expression for a particle in a 3D cubic box of length capital L. General expression for the energy is nx square plus ny square plus nz square. And the energy we are given as 14 h square upon 8 ml square is equal to nx square plus ny square plus nz square into h square upon 8 ml square. This term gets cancelled. What we are left with, that nx square plus ny square plus nz square is equal to 40. Right? What we are left with, that should come out to be equal to 14. The value should be coming out to 40. We get that nx square plus ny square plus nz square is equal to 40. Now, in order to find the degeneracy, what is the degeneracy state? That video is, I will leave the link of that video in the description. There you can go and see for yourself that how do we calculate this degeneracy. Now the degeneracy is basically the combinations of nx, ny and nz such that the sum of their square gives me 40. It is the combination of nx, ny and nz which will give me sum of the squares, which will give me 40. Now let us see what value. Now, if we put nx is equal to 4, it is very clear that neither nx nor ny nor nz can be 4. Why? Because if we put nx equal to 4, what we'll get? 4x square of 4 is 16 and we have here 14. It becomes greater than 14. So nx cannot be 4, right? So now, and we know that value of n varies from 1, 2, 3 and so on, right? 1, 2, 3, 4 and so on. Values of n for any particle will be, n is what is n? N is the principal quantum number and values of n always varies from 1, 2, 3, 4 and so on, right? Now, if we put value of 4, we are getting 16 for only single term. That is, values will be coming out to be greater than greater than 14. So, n value cannot be 4. So, what we are left with now. So, now from here, what we can say that n is nx, ny and nz can have any values between 1, 2 and 3. Right? Now let us put first nx equal to 3. Nx equal to 3 means nx square will be 9. If you put nx is equal to 3, that means nx square will be 9. Now if we subtract 14 from this, 9 from this 14, what do we get? 14 minus 9, that is equal to 5. Can I break it in any way such that it is the sum of squares of a number? I can write 5 as 4 plus 1. Can I write 5 as 4 plus 1? Now 4 is the square of 2 and 1 is 1. The square of 1 is always 1. So what we get is that if nx is equal to 3, then ny is equal to 2 and nz is equal to 1, or what else can we? Nx is equal to 3, ny can be equal to 1 or nz can be equal to 1. Sorry, is equal to 2. This is the second combination. Now if I say that ny is 3, ny is equal to 3, then what can happen? Either nz is equal to 2 and nx equal to 1, or nx is equal to 2 and y is equal to 3 and z will be equal to 1, and nz will be 1. And if you take nz is equal to 3, then what are the chances that nx is equal to 1 and y equal to 2, or nx is equal to 2 and y equal to 1 and nz 3. So how many combinations are there? One, two, second combination, third combination, fourth combination, fifth combination, sixth combination. So total of 6 combinations are possible, therefore the degeneracy is 6. The correct option is option number C, that is 6. So the correct option for this question will be 6. I hope it's clear. The degeneracy of the energy state with energy equal to 14 mg square upon 8 ml square in a 3D cubic box of length L will be 6. I hope it helps. I hope it is clear. Alright. Now let us move to third question. This is the last question for this video. In this question, it is given that the difference in the energy level of n equal to 2 and n equal to 1 is equal to 6. Then what we need to find is, the energy difference between energy level 3 and energy level 2 for particle in 1D box. What is the general formula for 1D box? Energy of 1D box is equal to n square h square upon 8 ml square, right? The general formula for the energy for a particle in 1D box is E E1d was equal to En square h square upon 8ml square. Now for n equal to 1, for n is equal to 1, E1 will be equal to, for n equal to 1, E1 will be equal to h square upon 8ml square. Equal to 8ml square. Wait a minute, I just rub this. E1 will be equal to h square upon 8ml square. For n equal to 2, E2 will be equal to 4h square upon 8ml square, right? And for n equal to 3, E3 will be equal to 9h square upon 8ml square, right? And when you put n equal to 1, 1 square is 1, 1 into h square will give me h square. For n equal to 2 means n square will be 2 square, 2 square is 4, 4h square upon 8ml square. For n equal to 3 means n equal to 3, 3 square is 9, 9 into h square will give me 9h square upon 8ml square. Alright. Now what are given is, now we are given E2 minus E1 is equal to 6. Now let's put this value E2 and E1 here. If we subtract E2 from E1, what I will get? I will get 3h square upon 8ml square equal to 6. Right? Right? 3h square upon 8ml square is equal to 6. From here what I can write is, h square upon 8ml square is equal to 2. This implies 3h square upon 8ml square is h square upon 8ml square is equal to 2. So far what we have got, value of h square upon 8ml square is 2. Now what we need to find is E3 minus E2. Now let us subtract E3 minus E2. E3 is 9 h square upon 8ml square, E2 is 4 h square ml. If we subtract E3 minus E1, what I will get? I will get 5 h square upon 8ml square, right? And the value of h square 8ml square is 2, is equal to 5 into 2, that is equal to 10. E3 minus E2 is equal to 10. So our correct option was option number D, that is the energy difference will be between E3 and E2 in terms of this units will be equal to 10 units. I hope it's clear. That's all for today's video. In the next video, we are going to discuss previous year problems from computation of operators from year 2012 to again to June 2013. I hope it helps. And then in the subsequent video, we are going to discuss about some more problems in particle 1D box from December 2013 onwards. Thank you.